And there's a couple things that we talked about in the last lesson about inverses. And I asked you if the function and the inverse were functions. And that's an important question for today, because an important fact about functions is they can be one-to-one, okay? And so a function is one-to-one if both the inverse and the function are both functions. So if the function and its inverse are both functions, then we say that a function is one-to-one. So we're going to look at what that looks like here. But first, let's review domain and range. So when we do domain and range, let's call this function here f. Okay, we're going to call this guy here f. And let's list out the domain and the range of this function. This is a good review for Unit 1 stuff. Where do I look for the domain, the x or the y values? Which one's the domain? The x values. So what are the x values here? What should be in my domain? Which ones are x values? 5, 4, 7, and 6. So that should be my domain. And we're just listing out the numbers here. We're not giving an interval because these are all points. These are not intervals. And then my range is the y values. So what values are in my range? 6, 2, and 8. Notice that there is 2 twice, but we just keep it in the range once. Now, is this function f a function? How do I tell if something's a function again? If there's any repeats in the domain. Were there any repeats in the domain here, in the x values? No, so this is a function. So yes, f is a function. There was no repeats in the domain. What's the one thing we want to remember about inverses? Switch the x and y. So if I'm going to switch the x and y here, what will f inverse look like? What will be the first point on f inverse? Not 5, 6, but 6, 5. And the second point will be not 4, 2, but 2, 4. And then 8, 7. And then 2, 6. So that's f inverse. Remember, I use this little -1 here in the power to talk about f inverse. Now, if I just switched the x and y, it should be really easy to find your domain and range here. Because what happens here? If I just switch the x and y, what will be the domain for f inverse? It will be the same as what? The range of f, right? Because the range of f was the y values, right? And if I just switch those and those are now the x values, what will be the range of f inverse? It'll be the domain now, right? They just switched because what did we do? All we did was switch the x and y's, right? So now the domain and range, the only difference in the domain and range of f and f inverse is that they just switch, right? So the domain will be 6, 2, 8. And the range will be 5, 4, 7, 6. Because they just switched, right? These were the x values. The domain for f was the x values. The range for f was the y values. And if we just switch the x and y, the domain and range just switch. So that's another important fact about inverses up here at the top, is that the domain of f is the range of f inverse, right? Because if those are the x values, then they switch. They are now the y values. And then the range of f is the domain of f inverse, right? They just switch. They're opposites of each other because we just switched the x and the y. So now, question, is f inverse a function? No. Did we have repeats in the domain of f inverse? Yes, because we had repeats up here in the range, right? So if there were repeats in the range up here and they flipped and became the domain, then this guy is not a function. So no, f inverse is not a function. So when I ask you if a function is one-to-one, there are two ways for you to think about it. One, it's one-to-one if its x values and its y values do not repeat. So no repeats in the domain or range. Or if both the function and its inverses are functions, right? Because if they're both functions, then that will mean no repeats on either side, the domain or the range, right? So did we have no repeats at all here? No, we had repeats in the domain of f inverse, right? Or repeats in the range here. So f here is not one-to-one. We use this one-to-one colon notation. You can write it out in one-to-one with words, or you can write not one-to-one with that little colon. That means the same thing. So to be one-to-one, there can be no repeats at all, domain or range. Does that make sense? Because you need both the function and the inverse to both be functions. So I would like you to try this next one on your own. Number 2. Alrighty, so your domain for f should be 5, 9, 10, 4. If you rewrote it in order, great. I did not rewrite it in order, but that's fine. Your range should be 4, 3, 2, 1. And is f a function here? Do we have any repeats in the domain? No, no repeats in the domain. So yes, f is a function. And then when you find the f inverse, all you need to remember is switch your x and y. So 4, 5, 3, 9, 2, 10, and 1, 4. So then your domain and your range, they just flip, right? They literally just flip-flop. So now your domain is 4, 3, 2, 1. And your range is 5, 9, 10, 4. And are there any repeats in this domain? Are there any repeats in this domain? No. So yes, f inverse is a function. So is this function one-to-one? Yes, if there are no repeats in the domain or the range, so both f and f inverse are both functions, right? Then it is one-to-one. So yes, f is one-to-one because there's no repeats in the domain or range. So that's all that one-to-one means, is both the function and its inverse are functions. So you don't have repeats in the domain or the range, because if you flip them, the range is the domain of the inverse, and that's how you would know if the inverse is a function. Any questions about that? So if you have a graph, it can be hard to tell if there's any repeats in the domain and the range. So do you remember the vertical line test that we used to tell if something was a function? Well, if we want to know if the inverse is a function, we can use the horizontal line test, because we would be flipping it across y equals x. So if we want to know something is one-to-one, we can use the horizontal line test. And so the horizontal line test says, if you draw a horizontal line anywhere and it intersects more than once, then it is not one-to-one, meaning the inverse is not a function, okay? So if I look at this graph right here, no matter where I draw a horizontal line, it only intersects the function once. So this one would be one-to-one. So this is in addition to being all of these already passed the vertical line test. We're starting with functions to start with, right? They already passed the vertical line test. So now we're looking to see, were there any repeats in the range, i.e. the domain of F inverse. How about this one, B? Does that one pass the horizontal line test? No, you can draw a line here or down here, and it's going to intersect way more than one time. So this is not one-to-one. C is a little funny looking, but it actually is one-to-one, because wherever I draw this line, it's still only going to cross the function one time, even though it goes slowly out like this forever, right? It's still going to get a little bit bigger every time. So this one is one-to-one, because there's no place where you can draw the horizontal line and it intersects more than one time. All those horizontal lines only touch it one time. How about D? Is this one-to-one? If I draw a horizontal line here, how many times does it touch the function? Twice, so not one-to-one. So that's a way to look at the graph and tell. So if you're looking at the points, you want to look for no repeats in the domain and range. If you're looking at a graph, you want to see if it's a horizontal line. Because here what's happened is now, for each of these x values, they have the same y values. So I have had repeats in the range now, is what's happening with the horizontal line test. Okay, let's flip it over and let's talk about graphs and graph tables with inverses, okay? So I want you to kind of highlight here the tables that we have. So here they've given us a table for F, and they've given us a table for G. So see, oh, hold on. Boop, boop. I think my internet is being a little slow. Let's try this again. They've given us a table for F, and they've given us a table for G. Can you make me a table for F inverse then? This part right here is the table for F inverse. Can you make me a table for F inverse? Yeah, what's the one thing we remember about inverses? Swap the x and y. So instead of -2, 3, what will be here for F inverse? 3, -2. So go ahead and finish those tables for F inverse and G inverse. You're just flipping the x and y's. So for the first table, you should have 3, -2, 4, -1, 4, -3, or I'm sorry, -3, 4, 8, 5, 10, 8. For the second table, you should have 8, -3, 5, 0, -1, 3, -2, 4, and 4, 10. So we took for F inverse, we took F, and we flipped the X and Y. And for G, to find G inverse, we flipped the X and Y. So now we're just going to use our tables to find these values. So this one says to find F inverse of -3. So if I want to find F inverse of -3, which table should I use? F, G, F inverse, or G inverse? We want to use F inverse, right? If we want to find F inverse of -3, go to your F inverse table. Remember, this is your X value. So go to the X value of -3, and what does this say the F inverse is? 4. So go ahead and find the next one. So we just did this one. I want you to find G inverse of 8. So use your G inverse table and find G inverse of 8. So if you go to your G inverse table, this is your X value, right? So look in the X column for 8. And what does it say G inverse is? -3. So those ones are pretty easy, right? You're just looking. This says G inverse of 8. So which table should you be using? G inverse, right? Going to the X value, 8, just like we used tables before, and then it's -3. Don't use the G table. This doesn't say G of 8, right? It says G inverse of 8. It doesn't say F of 8. It doesn't say F inverse of 8. It says G inverse of 8. So now let's do some of these guys. This one here, F of G of -3. What do we call this? What special word do we use to describe this? We just had a whole test on it. Starts with a C. What is that called? Are we multiplying F and G together right there? A composition, right? F with G inside, that's a composition. Okay, so back to compositions here for a second. Right, this is F with G inside with -3 inside. So where do we start first? On the inside. So find G of -3 first. Not G inverse, G. Use your table for G. So if we go to the G table, that's right here. We go to the X value of -3. What does it say G is? 8. Then what do we do with that answer when I'm done for the next step for a composition? You got to plug that back inside, right? Remember, this is how compositions work. So G of -3 is 8. So then you'll have F. And what should I put right here? What was G of -3? 8. So put an 8 right there. And now use your F table to find F of 8. So our F table, if we go over here, when X is 8, what's F? 10. So I want you to do this last one on your own. F inverse of G of -3. This is also a composition. So start on the inside. G of -3, look at your G table. At -3, G is 8. Plug that back in. So now we have F inverse of 8 And now you're going to use your F inverse table. So if you go to your F inverse table, go to 8, and F inverse should be 5. So your answer should be 5 here. So as long as you can make those tables for F inverse and G inverse, this is just the same things as what we were doing before. Any questions on that one? Okay, so now the last thing that we're going to talk about today is how to tell if two functions are inverses of each other, okay? So if you come down to these bottom problems at the bottom here, I am going to have you change one little thing because there was a little typo. So this right here should be a negative 2, x minus 2 down there. These last two are just going to be extra practice if you want to try them. We're going to do A and B together here. But if you do try that one, make sure to change that to a minus 2. So here, they have given me two functions, and we want to see if they are inverses of each other, okay? And so how we can tell if they're inverses of each other is using a composition. If we take F inverse and plug F in, and we get out x for our answer, and we take F and plug F inverse inside of that, so we switch them, and we also get x out for our answer, then that means that these are inverses of each other. This is probably going to be the hardest thing that we do in this section because we have to go back to inverses again, and we've got to simplify, okay? So let's first start with, we will do F of F inverse. So we'll start with F on the outside and F inverse inside. So they told us our F inverse equation is x plus 3 over 2. So we're going to plug that into F here. Right? Remember how we do compositions? You plug that in. We don't, right now we can't find a value for F inverse, right? So we have to put the equation, the whole equation in there. And then this says we're going to take the F equation and plug x plus 3 divided by 2 into the F equation, right? That's what a composition says. So then we're going to take the F equation. So that's this guy right here. 2 times x. And then x is going to be, we're going to replace this guy in here. So we did 2. We put all of this in for x, and then what do we still have for the F equation that we need to write on the end? Minus 3. And now our goal is to simplify this and see if we get x. So first, let's go ahead and multiply. When you're multiplying a fraction, you just multiply the number by the top. So you'll do 2x plus 6. You don't multiply the number in the bottom. So do 2 times x, 2 times 3, and you'll get 2x plus 6. And then we still have the minus 3 on the outside. Does PEMDAS say that we should divide first or subtract first? Divide, right? PEMDAS says divide first, so we're going to divide both of those things by 2. What happens when I do 2x divided by 2? Just 2, just x, right? 2 divided by 2 will be 1. So you can write 1x, or you can just write x. Those are the same thing. What's 6 divided by 2? 3. So plus 3, and then bring down your minus 3. So we did 2x divided by 2 is 1x, 6 divided by 2 is 3. Subtract 3. Now can I add and subtract these numbers? What's 3 minus 3 going to be? 0. So this will just be x. So did we end up with just x here? Yes. So now if you do get x, usually it will also work the other way, but we're going to go in and check that way just to be sure. Okay, so if you got x with the first one, it will probably work the other way. So now we're going to go do the other way. So we're going to do F inverse of F. So we're going to put F inverse on the outside and F on the inside. So we'll have F inverse of 2x minus 3. So we're going to take our F inverse equation, and wherever there's an x right here, what are we going to put in here for this x? 2x minus 3, right? That's what the composition means. So we're going to put 2x minus 3 in here for this x. Then you'll have plus 3. So we put 2x minus 3 in there for that x. We'll have plus 3, and then that's all divided by 2. So we put 2x minus 3 in there for that x. Now, because all of this is in the top here, that's kind of like parentheses. So we want to start up here first. So we got to start with minus 3 plus 3 first. So what's minus 3 plus 3 going to be? 0. So that'll just be 2x in the top divided by 2. And what happens if you do 2x divided by 2? You get x. And so these are inverses. So for this problem here, we'll start by checking g of g inverse. So we'll do g with g inverse inside. So we'll put the square root of x minus 1 inside of g. So we'll take the g equation, and where there's an x, we're going to replace that with the square root of x minus 1. But we're squaring all of that, and then plus 1. So we put this in for this x. Now when we square a square root, it goes away. So now we just have x minus 1 plus 1. Minus 1 plus 1 is 0, so we'll just have x. So that direction, we've got it. So now let's go the other way. G inverse with g inside. So now we'll take g inverse and put it inside of g. I mean the other way around. G inside of g inverse. So now we'll take this x and put x squared plus 1 in there for this x right here. Now we have to do the addition and subtraction first because it's under the radical. So plus 1 minus 1 is just x squared, and then the square root of x squared is just x. So this also works. So yes, these are inverses of each other. All right, down here, we want to see if f and g are inverses of each other. So we're going to check f of g first. So we'll take f and plug g inside. So we're putting g inside of f. So we'll take our f equation. So the x will be here in this first part. Then we'll have a plus 5 divided by 3. So then we're going to plug this part in here for the x. So we'll add those 5's together, and we'll get 3x plus 10, and then divide by 3. And we'll get 3 divided by 3 will be x, and then 10 divided by 3 is not a nice number. So we'll have x plus 10/3. So this is not good because this is not just x. So these are not inverses. And then over here, we just wanted to make sure that we changed this to a minus sign here. So this should be the cube root of x minus 2. So first we'll check f with g inside. So we'll take our f equation right here, and we'll replace the x with this part inside. So we'll have all this stuff cubed plus 2, and all this stuff inside here goes inside the cube. So we'll start with the exponents because PEMDAS says start with the exponents. So we'll cube the cube root. Well, that will undo it. Those will cancel each other out. So you'll just be left with x minus 2. Then you have your plus 2 on the end, and minus 2 plus 2 is equal to 0. So that'll just be equal to x. And then we got to check the other way as well. So we'll put g on the outside and f on the inside. So now we'll take our g equation, and where there's an x, we'll replace that with what's inside here. So we'll take our g equation, which is the cube root. We'll leave this spot for the x in the front, minus 2. And then in that spot, we'll put x cubed plus 2. Now we got to start with the stuff under the radical first, so we'll do the 2 minus 2, and we'll have the cube root of x cubed, because 2 minus 2 will be 0. And then the cube root of x cubed, those will undo each other, so we'll just be left with x.